We're solving problem 4 from the 2024 F equals MA exam. A bouncy ball is thrown vertically upward from the ground. Air resistance is negligible, and the ball's collisions with the ground are perfectly elastic. Which of the following shows the kinetic energy of the ball as a function of the time? Assume the collisions are too quick for the duration to be seen in the plot. So here we have our answer choices of graphs. And, well, let's just start to understand the problem. It says that they have to be perfectly elastic, which means that the ball bounces up to its original height. So, say if I dropped a ball from a height from here, if it were perfectly elastic, it would bounce up on my hand with no additional forces. And let's just, we have these several graphs. And, well, we can use a couple of equations to help us solve this problem. Since the y and x axes are in the kinetic energy and the time that goes on, we can use the kinetic energy formula. K equals 1/2 mv squared. And velocity, and the v is velocity. We also know that velocity as a function of time equals our initial velocity minus gravity times time. So we have this function of velocity, we can plug it into our kinetic energy equation to get K equals 1/2 times m times velocity initial minus gravity times time squared. Well, now when you put it in this form, we see that this graph, or this equation represents a concave up parabola. So, let's look at the answer choices now. Well, we obviously see that C is incorrect because it is not in fact a parabola, it has straight spiky lines. A is also incorrect as it is not concave up, and this and kinetic energy does not increase as a function as a curve like that. It increases like this, more of a parabolic shape, not the inverse. So we can call that incorrect. And there's also one more we can easily mark incorrect. We can mark E incorrect as there are no discontinuities or jumps. We see, or at least in the problem paper, the kinetic energy always resumes to its full height, but it never shows the gradual increasing of kinetic energy. There's just, you drop it and then it increases instantly. There's no discontinuity jumps. Now we're kind of stuck between D and B. Well, let's look at B. This is a parabola, a perfectly good parabola. Well, this is kind of curved at the top. And, yeah. So, basically, well, B, it's incorrect. It's a parabola, and there should be a time at the top where it spends most of its time hanging. Kinetic energy decreases to 0. And then there's a point where the kinetic energy is equal to 0 and then starts to increase. So that goes for a point, not just a curved line. That's incorrect. Now our answer is D. And why? Well, because we see that the kinetic energy as a function of time, as time goes on, it is gradually kinetic energy increasing, like in a parabolic way. And it always meets at these singular points at the top. So D is our answer for this problem.